Hello, I am Jahan. Today we will be talking about number congruency. So, what is number congruency? Number congruency is when two numbers have the same remainder when divided by a certain number x. For example, 5 and 8 are congruent modulo 3 since they both have a remainder of 2 when divided by 3. Now that we have established the basics, let's move on to something more interesting. If two congruent numbers are raised to the same power, they will still be congruent to the same number. For example, since 5 is congruent to 8 modulo 3, 25 will also be congruent to 64 modulo 3. Also, any number modulo 10 will give the last digit, while any number modulo 100 will give the last two digits, and so on.
Hello, I'm Ming Yang and I'll be talking about the example questions. So first of all, let's talk about this. What is the last digit of 7 to the 7 to the 7? So last digit, this basically wants you to find it mod 10. And basically, to find mod 10, we need to consider 7 to the n mod 10 and then set n to be this. So for 7 to the n, right? 7 to the 1 is 7 mod 10. I'm not going to continue writing in mod 10s for simplicity. So 7 to the 2 is 9 mod 10. 7 cubed, you just multiply by 7 on both sides. And 9 times 7 is 63, so it's 3 mod 10. 7 to the 4 is 1 mod 10, and after that it repeats, because 7 to the 5, you just multiply 1 by 7, you get 7. So this pattern will repeat. So you notice that it depends on the exponent 1, 2, 3, 4, and notice it loops back every 4 times. So it depends on the remainder when it's divided by 4. So this is 1 mod 4. This is 2 mod 4. This is 3 mod 4. And this is 0 mod 4. So to get the last digit, we just need to consider the exponent mod 4. So the exponent in this case is 7 to the 7. So let's consider 7 to the 7 mod 4. You can do this really easily. 7 to the 1 is 7. Oh, sorry, not 7. What am I doing? It's 3. But notice that 3 can also be minus 1 mod 4. Because 3 minus 4 is also minus 1. So it can be minus 1 mod 4. And so 7 to the 7 is minus 1 to the 7 mod 4. And hence 7 to the 7 is minus 1, which is 3. So you get the exponent to be 3 mod 4. We can find it here. And so the last digit is 3. That is our answer. Okay, the next question. This is from SMO 2011 Junior question 10. In the set of 1, 6, 7, 9, which of the numbers appears the last digit for n to the n? So 1, you can really quickly see that 1 to the 1, it gives 1. For 6, right? You can, okay, before I go into that, to get the last digit of n to the n, you need to consider the last digit of n raised to itself. Sorry, the last digit of n raised to n, to be more clear. So 6 or 6, you can notice that 6 to the 1 is 6, 6 to the 2 is, will also end in 6 because 36 ends with 6, 6 to the 3 also ends with 6. Oh, this is mod 10, of course. So 6 will obviously appears the last digit for any number that ends with 6. Okay, let's look at the odd numbers now because only the odd numbers are left. So 7 and 9. Okay, let's look at the powers of 3. So you have 3 to the 1 is 3 mod 10. 3 squared is 9 mod 10. 3 cubed is 7 mod 10, and that's our 7. 3 to the 4 is 1 mod 10, and this pattern repeats. We have our 7 and we have our 9. But, okay, for 7, 3 to the 3 is obviously 7, so that just accounts for it. But for 9, notice that 3 squared equals 9, and basically this repeats every 4, so this has to be the exponent has to be 2 mod 4. So if it's 2 mod 4, the exponent will be even. That means that the base cannot be odd and the exponent is even at the same time. So this 9 is not a valid 9. Let's skip 5 because 5 is the same case as 6, where every digit is just 5. So let's look at 7. So 7 to the 1, you get 7. 7 squared, you get 9. 7 cubed, you get 3. 7 to the 4, you get 1. So this 9 is the same as before and it's invalid. Let's now look at 9. So 9 to the 1, you get 9. 9 squared, you get 1. And 9 cubed, you get 9, and so on. So this pattern repeats in chunks of 2. Notice that 9 is for every odd number, so this works because 9 is odd. The base will be odd, the exponent is also odd, so this can work. In fact, 9 to the 9 ends with 9. So this works. Everything here works, so the answer is E.